Hey Maths Legends, you don't need to get into a frizz when you're trying to enlarge 2D objects. So today we're going to be looking at how we can enlarge these 2D objects using their properties and making them bigger. Alright guys, good luck. Okay guys, so the first thing we're going to be looking at is scale factor and scale. And as you can see over here, we have an object that has three squares long. So we're going to be using the grids in the back behind to help us out. So if we look down here, we've got 1, 2 and 3. So this is 3, okay? And then we go across the top, looking at the height, we've got 1 and 2, okay? So using those grids, if we try to enlarge this, now we're going to enlarge this to a scale factor of 2. So looking down here, we're actually going to double it, but we call that scale factor of 2. So when we go 2, we say, well, scale factor of 2, we say 2 times 2. If we look up the very top here, we've got 1, 2, 3, 4. And we know that 2 times 2 equals 4. Down here, we do the same to this side. Okay, so 3 times 2 is 6. Let's see if we're right. 1, 2, 3, 4, 5, 6. So we're 6 down there. So we have now enlarged the shape A into B to a factor of 2. So we've times them all by 2. Okay, so A effectively, B is twice as big as A. So we look at scale factor, very similar to what we might look at scale when we're looking at a map, and we say that one of those little squares could be 100 kilometers. Okay, 1 centimeter could be 100 kilometers. So we're looking at scale. So the same is with scale factor. And builders use these sorts of things, or cabinet makers, to look at how they're building their projects. So it's a good thing to understand. All right, let's go to the next one. All right, very quickly, this one's very similar. So we've got this little triangle down the bottom there, okay? And we're going to triple this. So we're going to look at it as it's a scale factor of 3. Okay, so this is a scale factor of 3. So we're going to times it by 3. And you can see what they've done here. They have one little triangle here, and then what they've done is they've just put 3 together. That's 1, that's 2, and that's 3. So we've gone 3 times. And across the bottom, there's 1 there, and they've gone 1, 2, 3. So now this large shape is now 3 times bigger than that small shape. Okay, so we're given a scale factor of 3. One way you can look at that is 1 times 3, and then 1 times 3 down the bottom there. So 1 times 3 is 3. That gives us our 3 here, and then that gives us our 3 there. So scale factor of 3. All right, a little bit more in depth here. You can see that we've got our objects over here. I'm going to make my pen a little bit bigger so it can stand out a little bit clearer. So here we go. We've got this little square, this little rectangle here, and we're looking at it. It's a scale factor of 2. Okay, so we've got 2 over here and 1 over here. So what I'm going to do is I'm going to draw that by light. So 1 times 2, I'm going to draw my line down through there. And hopefully you'll be using a ruler when you do this, not like Mr. O'Shaughnessy. And then 2 times 2 is 4. So 1, 2, 3, 4. And as I bring that down through here, I join up my sides using my ruler. And now I can say, well, that side is now 4. Okay, because 2 times 2 is 4. And then 1 times 2 is 2. So there we go. We've got a scale factor. So my second rectangle is twice as big as my top one. All right, let's look at this one now underneath. Okay, we'll go to C. I've got 2 times 3. So I know that I'm going to have to build mine bigger. So I'm going to start from the bottom here. So 2 times 3 is 6. So I've got to go up 6. 1, 2, 3, 4, 5, 6. And then 2 times 2 is 4. 1, 2, 3, 4. And then all I do is go down, across, and now I've got, this is 4, because 2 times 2 is 4. Okay, so 2 times 2 equals 4. 4 across there, and 3, 2 times 3 equals 6. And I've gone 6 down there, okay? All right, let's look at the next ones. The next one's a tiny little bit different. We're looking at 3. So I can see that's a 2 there, okay, and I can see that's a 1 there. Remembering that when I'm looking at my enlargements, I join up my 2 at the end. I don't worry about the diagonal. I do that at the very end, okay? That was our hack that we learned, okay? So it's a really important hack. So let's look at the first one. So I join up down the bottom, so that's 2. So I'm going to go 2 times 3 is 6. So I'm going to go down 6. 1, 2, 3, 4, 5, 6. All right, so I'm going down 6. So 2 times 3 is 6. 1 times 3 is 3. 1, 2, 3. And then the big hack that I was talking about before is joining up the diagonals at the end. So finding the points where they end and then joining the diagonals at the end. Rather than trying to figure out where those diagonals go, it's just easier to get your ruler out and rule them across at the very end. So that way you know you're right. So now 2 times 3 is 6. 1 times 3 is 3, okay? All right, looking at the one below it, I've got 2, and then on the bottom, I've got 4. So 2 times 2 is 4. So I go 1, or let's see, 1, 2, 3, 4. Okay, so I've gone across 4. Down the very bottom though, I'm going to look at it. I'm going to say, well, that's 2 times 4 is 8. So I'm going to go 8. 1, 2, 3, 4. 1, 2, 3, 4. And then at the very end, I'll just join up my line so it's nice and even. Okay, and that gives me my 8 down the bottom. Okay, and now A is twice as big. Now, when you're doing that, you might think, hey, Mr. O'Shannessy, you had to do that because you've got 1 going up through here. And you're right. I needed to make sure that I was going down 2 here. I need to go 1 bit lower. Okay, 1 lower because I'm making it twice as big. All right, I hope that made sense, guys. Feel free to watch that one again. That's a bit tricky.